Thank you, everybody. And thank you for the folks that organized this conference. It's a big undertaking. And I tried to be here really early. I left 2 hours ago and just got here about a minute and a half ago. But I'm here. So actually, let's just dive in and get started. So the presentation is Start Small and Scale. And when I started small this morning in my garage, there was no traffic when I turned out onto the road in Chino. Scale happened, and this is why we love Southern California, right? So, why is it not advancing? So I'm Carol. I'm actually a member of Project Jupyter Steering Council, a core developer. I'm also a core developer and steering council member for Python, the software language, and do a lot of work with Interact and have the pleasure of every few weeks co-hosting the webcast, Open Source Directions, which actually profiles the different projects in open source that are often used by data scientists. So really, my love is creating tools that educate and empower people. The last 5, 6 years working on Jupyter has been incredibly rewarding, and it's amazing to see the different folks that are using it in so many different ways. And we'll talk a little bit more about Interact and how that fits into scale a little bit later. But first, what's data science? There's a lot of different definitions, so I'm going to give you my definition so that it frames the context of this talk. I view data science as using data responsibly to solve real-world issues and improve human lives. Now, that's my definition. It has nothing to do with technology, software, tools, but really focuses in on responsibility and the world and all of us humans. So I want to tell you a real quick, real-world tale about making predictions at scale. I live in lovely southern San Diego, and when I look at the weather outside, other than yesterday and the day before, it's typically high 60s, sunny, no clouds. It's pretty easy to predict the weather in San Diego. Well, earlier this year, about a month and a half ago, I was in Europe at the European Medium Range Weather Forecasting Group, which is a big research institution that collects tons of data about weather across the world, and they are the ones that actually do the weather forecasting for the next 12 to 14 days for the world. As of December 2018, they have 255 petabytes of operational and research data, and they're adding 250 terabytes a day. And overall, they have more than 400 billion fields stored in their Mars database. So that's a bit of a scale, right? So earlier this year, I spent some time in Tokyo visiting my daughter. She's a Japanese translator. The weather was gorgeous. And on October 12th was when I landed in Heathrow to go visit the weather agency. And earlier that week, the Sunday before I landed, there was a big typhoon heading towards Japan. And this is actually a picture of the weather forecast that this institution had made. And Japan, I don't know if you can really see it, but it's directly under the green and red. So looks like a direct hit in terms of probability a week before. If we go to I believe it's the Tuesday before I landed in Heathrow, this is what the typhoon looked like out over the ocean. You can see the eye. It's pretty massive. And in terms of context, the Wednesday before I landed. That was Typhoon Hagibis. And if you look at it, it's probably as big across as the entire country of Japan. And at that point, it was classified as a super typhoon. And the actual eye, which you can maybe see a little bit on the bottom, is 60 kilometers in diameter. So, little tiny storm. So I get off the plane in Heathrow, and all of a sudden my phone starts binging. Ding, 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 ding. I have a ton of messages from my daughter. And usually she's pretty my independent one, and nothing really phases her. And she's like, Mom, in case you haven't seen, there's a super typhoon headed straight towards Tokyo. I've been translating emergency messages for the entire day, but I thought you want to know. And so in response, what do I say? I can't do anything. I'm like, be safe. And to that response, she sent me this picture. And this is the eye getting close to where she is in Tokyo, and the sky actually changes a different color because of the pressurization and the way light goes through it. So fast forward a little bit further. The eye of the storm kept going, and the storm kept going across Tokyo during the day. My daughter's like, yeah, I'm on the 4th floor of my apartment. Hopefully the windows won't explode in, but I guess I could probably run the 10 minutes over to the government office if need be. And she's like, or I could just like huddle in the bathroom and lie on the bottom of the thing. And I'm thinking, okay, this is the irony of going and speaking at a weather research institute, and having this happen in the background was sort of surreal. And she's like, oh, there was a fire. Ooh, there was just this. Oh, and we had a little bit of a volcanic eruption. And there's a tornado that's coming through. And from that news, what I learned was some towns like Hakone near Mount Fuji had a meter of rain in less than a day. Some areas got 40% of their annual rainfall in that one day. They had urged 7 million people to evacuate their homes and go to evacuation centers, which was part of what my daughter was communicating out to folks. And they had over 27,000 troops and rescue crews deployed to help. So to quote my daughter, wind, water, earth, and fire, all that's left is for Godzilla to crawl out of the bay and vaporize Chiba. And at that moment, it sounded kind of plausible. And I was like, that's pretty cool. I'm going to leave it in my keynote. And, on a more serious note, the next day, it showed that the storm was passing through. The death toll was about 84 people at that time. 33,000 plus homes got flooded. And the Tama River, which is a big river that goes through Tokyo, had just crested to the banks where she was. And that was one of the things they were really worried that it was going to overflow because, everything's flat, sort of like it is in San Diego. Like when we get rain, we flood. And so why does this have anything to do with data science other than we use data to forecast the weather? Well, data science really mattered in this context because it helped us predict what was going to happen. So they had at least a week's warning to start mobilizing forces on the ground within the government, to start evacuating people. And had they not done that, the death toll would have been far higher than what it ultimately was. Overall, there was over $9 billion of damage done by this one super typhoon. And it's sort of astounding that In contrast, it was things that got lost as opposed to many people. And that is one reason that data science really matters. I'm going to give you another quick example of why I think data science matters. And with great scale of data comes great responsibility. And that responsibility starts with every single person in this room. The healthcare industry, there's a company down in San Diego. It makes little monitors that read glucose levels. And they have this whole integrated system around it. So the CEO had said in early November, this whole integration of healthcare data is really going to be the next frontier. So think about it for a moment. You're making a service and product that's measuring people's glucose level, and that is also alerting them and people who are subscribed to their stream that the glucose level's dropping, or time to take some intervention. Now, if you were doing that service as your own product, what would be some of the things that you would perhaps plan for? Well, one would be an outage. And stuff happens. Those of you that work in the infrastructure side of things, things break. And on the Friday night, right after Thanksgiving, they had a mysterious outage. They didn't announce the outage to their customers until the morning, Saturday morning, about 8 hours later, where they posted a brief notice on Facebook. Okay, but not all their customers are on Facebook. And I won't go into the story because, there definitely had impact on people. But it took till Monday to get the service partly restored. So if you were a customer using this, and I'm not really picking on them because it could happen in many different services that we offer. But this is an example of you are stewards of data. You are stewards of how the data is used. And at the end of the road, people's lives may depend on your data, such as with the weather. Southern California, Santa Ana winds, fire, really important. Those weather predictions help us avoid the destruction of fire here in Southern California. Even if you're in a business like Ticketmaster or Netflix, you probably see different traffic patterns if it's raining in Southern California for a week and people aren't going out, so they're going to watch things inside or go out to a show. So weather touches us in many different ways. So here's our challenge. How do we get from starting a service or starting with an idea and scaling it? And what I want to share are some practical examples of what I learned both at Jupyter and before in building up systems and services from the ground up. And it wasn't too long ago, 2014, that the IPython notebook changed its name to Jupyter Notebook. This is a picture of the classic notebook, one linear execution page that lets you combine prose and text and graphs. In 2014 in San Diego, Audrey Roy, Danny Greenfield, and I taught one of the first workshops using the notebooks. We took Jessica McKellar's Python beginner's tutorial, and we transferred it to notebooks. And we actually didn't teach from the notebooks. We taught from the command line, but all the notebooks were there on a separate screen, and they knew they were going home with those notebooks. So it really reduced the stress of learning, and it really helped people focus on the material because they knew they had it when they were leaving, and they could use it after they had gone. So fast forward to today, there's over 5 million notebooks on GitHub. If you had asked me in 2013, 2014, would I anticipate that? I probably would have said no. And I'm very glad that I was wrong. In the interim, Jupyter has sort of become the de facto standard for creating computational narratives and doing research with data. And I share this because oftentimes people think there's like a huge army of people that have made these many, many tools. Like there's many projects under the Jupyter umbrella. And actually, this is more or less the core team that's made the notebooks, Binder, Jupyter Hub. If you ever see them at a conference, please say thank you to them because pretty much all of them are underpaid and overworked. And but we take great pride in what we've done. And we're human. So we started small, we kept iterating, we grew. So the roadmap for the rest of this presentation is some practical advice on how to start small, how to explore the paths to getting to scale, because that can be a really tricky, like, which thing do I use? You know, is this going to work? Is it going to hold up under load? And we'll talk a little bit about that. And then, like the glucose monitoring company in San Diego, your job is not done when you deploy it. There also has to be a way to sustain it. And for those of you that are creating algorithms for machine learning, as it sits out there and is used, the models need to be updated over time because you're learning from them, bias is being introduced, and the model's never as good as the day you actually deploy it. So let's talk about starting small. When you're starting a new project, often the feelings are very similar to this. What do I use? Where do I start? Is it this? Somebody told me R that, Julia this, maybe Python, but Python's slow. And there's a lot of decisions to be made. And so you often wind up starting and looking at a notebook like this. It stays blank for a while. Maybe you type in a few lines of code, execute them, which is cool. But oftentimes, if I'm trained not as a software developer, but maybe as a social scientist, I may not be able to install things right off the bat, but I want to use them and explore them. So look for the tools in our industry where you can try things without installing anything. Binder was something that came out of the desire to share research and research papers. Unexpectedly, it has become very popular for sharing demonstrations, for running workshops, and it also far surpassed what we had expected. And as of last year, there were over 2 million binders launched on that service. And it's a free service. It's run by 4 people and the community, and those 4 people aren't dedicated towards it. It's a small percentage of their job. And, you know, there's also Colab and other things which have a lot bigger infrastructure behind it, but Binder has sort of become the de facto standard for running tutorials at conferences, doing workshops, and scale. We didn't really plan on it initially. So as you're looking at what you're building, what you choose for your tools will matter. at least initially. Many of you might choose Jupyter Lab because it allows you to have multiple windows and pull out graphs, things like that. I'm not going to go too far into Jupyter Lab because I think there's other talks about it here, but I'm happy to talk about it later. We'll just do a quick, well, maybe it's not quick. There's also Interact is an alternative tool which uses, some of the Jupyter folks, including myself, have helped build a React-based front end for the notebook and also components that can be reused. VS Code, we heard a little bit from the folks that are here from Microsoft yesterday and their work with integrating notebooks into their editor. PyCharm has done the same. So the tools are important because if you have a de facto standard like Jupyter, I want to share my notebook with a colleague in Singapore. Now, if they're using something that's kind of like a notebook but not adhering to the Jupyter standard, I won't be able to open it. I won't be able to execute it, which becomes problematic if you're doing anything with reproducible research or anything that requires like an accountability trail. Healthcare, government work often does. So choose your tools, choose open source standards because it's transparent. You know what goes into the actual product and projects. And there's also a lot of great stuff out there. And one of the things you don't want to do in this exploration phase is reinvent the wheel. There are tons of projects in the Python and R and Julia sphere that have great documentation, that have a lot of executable examples. Look there first when you're trying to decide what to pick. Because you will have people that have gone before you and gone through the pain of being the first initial users and probably improved it a lot by the time you get to it. After you've come up with some promising libraries, obviously install them. Looking on Conda Forge for community libraries that are up to date, that are easy to install with Conda, particularly libraries that have C components in addition to Python. Conda is definitely a preferred choice there. So we're starting. You guys have probably at this point built some notebooks, have a prototype, have used your tools enough, and now somebody comes to you and says, okay, this looks pretty good. So let's try and put this in production. So where do you start? Maybe you have folks in your company that can do it for you, which is ideal, but not always the case. Or they might say, oh, try it on a smaller scale and then we'll go. So how do you turn the feeling of there's no way I can do this into it's possible? Now remember, when we started building Jupyter Hub, which serves notebooks to groups of people, and it is what Binder is built on top of, we thought, maybe 30, 40 people will use it simultaneously, and we were wrong. It then went on to serve tens of thousands of users simultaneously. It's used at CERN for some of their research stuff. And there's no way to know in the moment where things are really going to go. You're taking leaps of faith as you do that. And it's nice when you can have some company in that leap of faith. So conferences like PyData LA, meetups, PyLadies, the Carpentries workshops, if you haven't been exposed to the Carpentries workshops, they are open source curriculum on data science and in libraries, science, and as well. And it's really good content, so I would really encourage that. But what you will learn from your peers will get you to scale faster than going it alone. Also, look at what academia is doing. There is a lot of work that is getting funded that actually is the cutting edge of data science right now. And how to use data science well within projects. And this is the 10 simple rules for reproducible research in Jupyter Notebooks is one of them. And it goes through, okay, how do you organize your notebooks so that you can have it documented, so that you can version it properly, so that you know what you've done 6 months later when your aged self, like myself, can't remember what they did 3 days ago. And also, it has really great tips on how to share those notebooks. And I have seen, predominantly in Asia, but in other places as well, notebooks being used for cross-training corporate teams. So customer service, engineering, marketing, they're all collaborating over a notebook. I've seen it used in public health settings. And yeah, so we're going to zoom through the rest of this because I was late, unless we can have some time for the break. Yeah, okay, good. So as you're building stuff, build, try, change, repeat, iterate. Iterating is how you get to scale. There are some great tools out there that I saw start in their infancy. One is a project called iPyVolume that lets you do 3D visualizations. It's really slick. It lets you do things like manipulating like the inside of somebody's body or a skull, but you could also translate that same concept to parts if you're a manufacturer, and it will scale to large data sets. There's another very new project out there for those of you that are in the biosciences called Napari that lets you take huge data sets and really zoom in with very little latency to get really small areas, and something definitely worth checking out. Another way to scale, say you want Jupyter Hub or you want Binder Hub, but you're figuring it's going to take a while to install it. We actually have some friends at the Turing Institute that have made one button deploy to Azure, deploy to Google, so that you can at least get up and running so that you can try it with a reasonable size group of people. Perhaps not production quality, but it's going to be solid, like you could do internal workshops, things like that, which is really nice because other people have done the work of pulling these vast different technologies together. And then it's also important while you're scaling to remember that things keep changing and to stay up to date with what's new. There's podcasts like Open Source Directions, Talk Python to Me. For those of you that are using Jupyter Notebooks or data science in general, there is a phenomenal newsletter that Tony Hurst puts together called Tracking Jupyter, and it is worth subscribing to because it has some of the most up-to-date information about new things that are coming out. So we're exploring, we're building, we're applying best practices. We feel pretty good, okay? We've got something that kind of hangs together at this point. Now we want to deploy it and sustain it. And there's a lot more nuts and bolts in that, I'm not going to lie. There is a project called Voila that will let you directly serve your notebook to the web. the advantage of that is that in one command, voila, something, it will actually deploy it. And that is actually under the Jupyter organization right now. Production data at scale. Matthew Seal, who's out in the audience, who I've worked a lot with, had a talk yesterday about paper mill. Netflix uses a whole bunch of data and at scale and have open sourced a lot of really good work. And I would definitely recommend checking it out. Papermill itself will parameterize and run notebooks for you. Scrapbook, which Matthew did a lightning talk about, and I wanted to do a GIF of it, but it lets you record and read samples and store it out to S3 or other places. Bookstore stores notebooks, and Commuter helps you share notebooks. And these enterprise data workflows, Netflix isn't the only one. So, look around, see what other folks are doing, because you can save yourself a lot of time. Jupyter Hub scales. You can use it on Kubernetes. You can use it on bare metal. It's, supported MOOCs of 10,000 or 100,000 folks. It supports all of Berkeley's intro classes and more. Again, you can deploy your own binder hub. Easy way to share notebooks. We've actually made it so now that we have federated it so that we're not the only ones bearing the cost of the MyBinder service. And other research institutions are actually helping with that. And I mention this because all of this code is free and open source. Even the deployment information, other than security keys and things like that, is open source. The Turing Institute put together some good work about how to make a binder, how to go from notebooks to something that's shareable. One of the folks from the Turing, basically she did a notebook while walking her dog in the park and deployed it all from her cell phone. And this is pretty cool, actually. Then there's other projects like Pangeo, which combines one of my favorite projects, Dask, and as well as Xarray and Iris, to provide a platform for open geoscience research. And it is also open source. And it's actually the first time that Jupyter has gotten an NSF grant, because the NSF views it as a way to offer at scale these services and the suite of research tools in not just geoscience, but they view it as a model that then can be used in bioscience, and pick your favorite science or social science from there. So, deploying, sustaining it, it's possible. So what are your keys for success? First and foremost, you have to choose to start. If you don't start, you will get nowhere. One thing that those of you that know me well know how annoying I can be, because I will often ask, why? Why do we need to add this? Why is this a good idea? And in many times, why is a much more important question than how. And I think our friends at the glucose monitoring company, had they asked, why would it be important to have a way to notify and send a message to all of our customers if our service is down, might have been a good thing to think about. Absolutely automate the boring stuff from start to finish. If you can automate something, it will save you time, it will improve your accuracy, and it also makes it much easier to hand off to other people. You're going to iterate, plan, execute the plan, change the plan as needed, and then repeat. Keep doing that. And as you're building things out, consider the complexity of what you're building. If you can't understand it, the likelihood of somebody else understanding it is pretty rare. Which is not to say you need to understand every little bit and piece, but you need to understand why you're doing something and how the big blocks go together. And you need to have a way to observe what's going on once you deploy stuff at scale. And perhaps the most important thing is people in every step of the project. People are the most valuable asset in a data science pipeline, data science projects, products, and with that great power comes great responsibility. So my call to action for you is get started, use some of the wonderful things that are in our ecosystem today so that you can use data responsibly, solve real-world issues, and improve human lives. And should you think something's impossible, remember, it's possible. And for our Southern California lovers who like surfing, this is a big wave from a couple months ago, and this woman is surfing, and she's like little tiny over in the corner, but the waves are just probably 10, 12 times the size of her. So you can start small, you can scale, and I leave you with that, and I am here all day, happy to take questions, and want to thank you for listening and for being here, and to the organizers for doing their thing. Thanks.